Hey viewers, welcome back to our YouTube channel. In this video, we are going to discuss about the longest consecutive sequence, where we are initially given with an array called nums, and at the end we have to return the length of the longest consecutive elements. What does the term consecutive refers to? Like I say that 1, 2, 3, 4. Here every element is been having the difference of 1, right? If I say that 5, 9, 11, these all elements are not consecutive because their difference is much greater than 1, right? The only elements which have the difference as 1, they are referred to as consecutive elements. And in this array we are given with the elements 104, 200, 1, 3, 2, and we have to return what is the longest consecutive elements sequence. And if I pick 1, does existing of 2 there in this array? Yeah, it is present. Then again 2 plus 1, which is 3, it is also present. 3 plus 1, which is 4, it is also present. 4 plus 5, nope. Therefore the sequence is 4, which is 1, 2, 3, 4, and we have to return the same thing. Got it? And you can see the another example which again starts from 0 and goes till 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. Up to 8, 0 to 8, therefore we're gonna get 9 elements, right? And the output is also same 9, and we have to do this in a time complexity of order of n. Got it? And let's simulate this with the most brute force solution. First of all, I am standing at the 0th index, right? And the sequence always starts from the current element, which is 100, and we're gonna check, does 100 plus 1 present in the nums. Let the array name will be nums, and gonna check that does the 101 present in the array? No, it doesn't present. Therefore we now move it forward. 4 plus 1, which is 5, does it present? No. Again move it forward. 200 plus 1, does it present? No. Again move it forward. 1 plus 1, yeah, which is 2. 2 is present. Therefore whenever we found 2, our new element becomes 2. Got it? 2 plus 1, which is 3. Does 3 present in the array? Yeah, it does present. Therefore now 3 becomes the new element. 3 plus 1, which is 4. 4 does present in the nums. Again take the 4. 4 plus 1, which is 5. 5 not present in the nums. Therefore we are going to check what is the length, which is 1, 2, 3, 4. 4, because we're going to get 1, 2, 3, 4 elements, right? This is the length of 4. We are not done yet, but move it forward. When we found 3 plus 1, which is 4 does present. 4 plus 1, which is 5, not present. The length is 3, 4, which is 2. But our global maximum is already updated to 4, therefore we're not gonna change it. And when we move it further, 2 plus 1, which is 3, 3 plus 1, which is 4, 4 plus 1, which is 5, 5 not present. Now the sequence becomes 2, 3, 4. The length is already 4. Here we get 3, not gonna update, and at the end we're gonna return this. And let's quickly simulate this brute force approach. And here we're gonna start iterating from the 0 element and goes till n. And when we see we're gonna start figuring out the sequence from the starting element. Let the current will be the nums of I, and the streak, or you can say the length, will be 1 initially, because 100 can make a longest consecutive sequence of 1, right? 1 element makes 1. And gonna take the global length, which is also 1. I'm gonna check that while the current plus 1 in the nums, it's a good sign. We're gonna go forward. The current will be incremented to 1. Got it? And at the same time streak will also incremented. And while this entire while loop done, at the end I'm gonna update the global length to the max of global length, current. Got it? And at the end just return the g length, which is the global length. And let's quickly discuss the time and space complexity for this approach. Initially, this loop takes a time complexity of order of n, and this while loop also takes a time complexity of order of n entirely. But here there is a hidden loop which most of the people can't figure it out. When we do this thing, why if current plus 1 in nums, it's gonna do a scan from the initial element to the element that we found the required nums current plus 1. If it is present at the end, we're gonna do end up a scan of order of n. Therefore, this only check can take a time complexity of order of n. Now see, order of n cube. The time complexity order of n cubic, and the space complexity is order of 1 because we are not using any external data structure. It's done. And yeah, we can see that the constants are 10 power of 5, the maximum length of the nums. N cube, no, doesn't pass because 10 power of 5 whole cube, which is 10 power of 15, no, only 10 power of 8 to 10 power of 9 are acceptable, right? Therefore, we are gonna optimize it towards a better one, and let's quickly see the better solution. Better solution, we are gonna sort the nums array and just take two variables, the global length which is 1 and also the streak which is also 1. Now we're going to start iterating from either 0 to n minus 1 or 1 to n, any one of them. I better choose this one, therefore I'm going to update it with that. I runs from 1 to n, any of them, because either I am standing at here, I'm going to check with the I minus 1 or I'm going to check with the I plus 1. It's your wish. And I'm going to said earlier like that if we have the same elements, then I don't want to take them into consideration. Therefore I skip them by one condition, like if nums of I not equal to nums of I minus 1. If they are both different, then I'm going to take into them into the consideration. And another important thing is like what the difference should be. What is the valid sequence? The sequence with having a difference of 1, right? If nums of I is equal to nums of I minus 1 plus 1, got it? Now if they are holding this condition, then my streak will be incremented, right? If we have the example like here 1 2 3 4 100 200, right? I'm at here, the 2 is equal to 1 plus 1. Now streak will be 2. Now streak will be incremented to 2. Again my I gonna move forward. We're gonna check 3 minus 1, 3 is equal to 2 plus 1. Again the streak will be incremented. When I'm at 4 is equal to 3 plus 1, the previous elements plus 1, the streak again will be incremented. And when I hit here, 100 is not equal to 4 plus 1. Got it? It should enter the else block. Now what should my else block would be? I'm gonna first take whatever the streak into the global streak, which is g length equal to max of global length comma the current streak that I have, and at the end now the streak becomes 1 because 100 doesn't have a property, like it doesn't hold the nature of having a consecutive with the previous elements, right? It entered the else block because it violates the condition, right? Having a difference more than 1, that's why it enters the else block, right? Therefore the streak will be again resets to 1. Got it? Now at the end I'm gonna return the global length. And now let's quickly discuss the time and space complexity for this approach. You can see that the sorting takes a time complexity of order of n log n, and this takes a time complexity of order of n, and remaining all are constants. Therefore the time complexity is order of n log n plus n, which is order of n log n nearly, and the space complexity is order of 1, but I can't say order of 1 because it depends upon the sorting algorithm you are using. But if we ignore the sorting algorithm, it gonna take a time complexity of order of 1, and it do passes the constraints because 10 power of 5 it gonna pass the constraints, but they explicitly noted that we could not use or they stated that we should use a time complexity of only order of n. And how can we avoid this? And the better optimal solution comes from the brute force. And if we see that the brute force have the couple of issues. One issue is it gonna checking the nums iteratively, like for current plus 1 in nums, it gonna take a time complexity of order of n. And how does this can be reduced? I know a data structure called set, which gives me a lookup in a time complexity of order of 1. Then why not we use this? Therefore the problem that we are facing with the brute force one is the looking problem. Therefore I can make sure it gonna take order of 1 by doing a num set, which is the set of nums. Therefore in this case I get a lookup of order of 1. Again I gonna update the name. If it is present in the nums set, then do the following things. And another drawback of this approach is that I am checking for each and every element, right? If I have the element like 100, I'm gonna checking for 101. For 200, I'm gonna checking 201. For 4, I'm gonna checking for 5. No, this should be avoided. Therefore, I'm gonna put one condition, right? For every sequence, like there are elements like 2, 5, 6, 3, 4, 7. Now see that the valid sequence here are 2, 3, 4, 5, 6, 7. But here we are doing for every element we are going to checking the while condition, like for 2 plus 1, for 3 plus 1, for 4 plus 1, right? We should avoid this. Therefore the condition for this is we have to pick only the element which is the starting of the sequence. If I have the sequence which is this, I am gonna only check for the starting of this sequence, which is 2. If I have another sequence like 100, 101, again and I gonna only check for 100 itself. For better understanding, let me pick an example: 1, 2, 3, 101, 102. For 1, I only do the while check, and for 2, I'm not gonna do because already 1 has done that, and for 3 again 1 has done that. Again for 101 and 102, I'm gonna only check for 101, and 102, nope, my friend had done, right? This makes sense. And we're gonna insert a condition before entering into the while loop that we have to do only for the starting of the sequence. And how we can know that it is the element is the starting of the sequence? Good question. Now when we are 2, so what is the element that is before it, which is 1? Does 1 present in the num set? No, it doesn't. So itself is the starting one. If it is a present of any element in the num set, then it should not be. Like if I say I am at the 3, now 3 minus 1, which is 2, does 2 present in the num set? Yeah, it does present. Therefore 3 cannot become the first element of the sequence. Got it? Now I'm gonna insert the condition. The condition here it is, if the I minus 1 not in num set. Got it? Whenever we found these conditions, specific condition, we're gonna try looking this. And let's quickly discuss the time and space complexity for this approach. Here it takes a time complexity of order of n. It takes a time complexity of order of n, and many people will fall into the trap by seeing the while loop. By seeing the while loop, they say that it also takes a time complexity of order of n, and the entire it is order of n into order of n, which is order of n square. But it doesn't, because we are not running the while loop for every element, right? We are only running for the first sequence. If I have the sequence as 2, 3, 4, 5, 6, I am only running at this condition, right? Because 2 minus 1 is not existing in the num set. At that time only I am letting it run in the while loop. For 3 minus 1, which is 2 present in the num set, because so therefore I'm not gonna let it run into this block of code. I'm gonna skip it and I'm gonna move it forward. And 4 minus 1, which is 3 is also present. Again I'm not gonna allow it into this block. Again the same thing happens here. Entire thing I only allow at the start of this sequence, right? This makes sense. And if you see that this entire block, this entire while block will run for a time complexity of order of n entirely, not for each and every I. If you have more confusion, let me pick like 0, 1, 2, 3, 4. These all are indexes, right? For 0 it's gonna run for order of n, for 1 it's gonna order of n, and same thing for this. In this case, for every element it's gonna doing the time of order of n, right? Therefore now the time complexity becomes order of n cross n in that case. But if you look at here, I have the index as this, and here I'm gonna take I'm running for how much length? 1, 2, 3, 4, 5. Yeah, 5 times. Here no, I'm not letting into the while block, right? Here it's also 0, here it's 0. Now see this, how interesting it is. I only running for few indexes and remaining all are taking 0. I'm not letting it into this block. Make sense? Therefore it's gonna take a time complex of order of n, plus it's gonna take a time complex of order of n. Now the time complexity becomes order of n plus order of n, which is order of n, and the space complexity is order of 1. You are not using any external space, right? Sorry, it's order of n, because whenever we are using the set, right, it's gonna take, if we all are unique elements, then we're gonna end up storing all elements in the set, and we're gonna take a time complexity of order of n. And if you could not believe that it is order of n still, then please do a paperwork on it, and you will still you can figure out it out, right? And if you really understood, and sorry, this is the optimal one, and really understood this problem, then please do like, share and subscribe. Thank you.